Hello everyone. My name is Yihao Li, and this is the final project. I just work on the home credit default risk prediction problem. The goal of the project is to build a machine learning module that predict whether a loan applicant will default on their loan. In this data set, I collected these two CSV on the left corner, and you can see the target equal to 1 means the applicant defaults, and target equal 0 means the applicant successfully repaid the loan. However, this project is not only about building the accurate module. This main focus is applying responsible AI principle, including like fairness and module interpretability and ethical consideration and the production and readiness, because the credit approval decision directly impact people access to the financial service. The module in the domain must not only accurate but also transparent and fair. And you can see I'm loading the data sets, and you can see the test data set on here. The training data set contains about like 5,821 rows and 122 columns. Then I just perform some of the basics exploratory uh, data analysis to understand the dataset structure and the target distribution. So one important observation is that the dataset is high imbalanced. So only around 8% of the applicant actually default. The imbalance is very important when evaluating module performance, because the module could achieve high accuracy simply by predicting that everyone will replay. So therefore, accuracy alone is not a sufficient metric. Instead, I evaluate module performance by using additional metrics such as like recall, precision, F1 score, and ROC, AUC, PR, OC. So this metric gives a more reliable view of the performance in imbalance classification problem. Okay, so let's go through to the pre-processing module. Like I just like uh remove the ASCII ID CUR column because it is simply an applicant identifier and does not contain predictive information. Then I just handle a known anomaly in the dataset. So the variable days employed contains value 365243, which is actually used as the placeholder for missing value. So I just replace that the value with a NaN. So next, I just create a more interpretable feature called age year, and which is derived from the days birth. So I also create like several financial ratio feature that helps to capture repayment ability, such as income to the credit ratio, annotating to the income ratio, and the third one is the credit to goods price ratio. So for the pre-processing, I use the pipeline that includes mating imputation for the numerical feature, the most frequent imputation for the category features, so one hot encoding for the category variables, and last one just is about like feature scaling for the numerical variables. So finally, I just split the dataset into the training and validation sets by using the stratified sampling to preserve the class imbalance. And uh, for the module training, I just train like two different module. So like first module is logistic regression, so which I use the baseline module. The logistic regression is useful because it is relatively simple and highly interpretable. So the coefficients help us understand how different feature influence the probability of the default. The second one is a random forest. You can see all the picture right here, and which is indelible module that can capture which is like indelible module that can capture more complex nonlinear relationship in the data. And by using the both module allows me to compare interpretability and the predictive performance. Okay, so let's scroll down the evaluation result. And for that, I just evaluate both the module on validation set. So for logistic regression, the module achieved like accuracy around like 0.68, recall around like 0.63. For the random forest, the accuracy increased like about 0.88, but recall drops to the about like 0.18. So this illustrates why relying only on accuracy can be misleading in the imbalanced dataset. So in credit risk modeling, identifying risky borrower, it is very important. So recall for the default class is also critical. So I also examine the confusion metric to better understand the number of the false positive and the false negative. And for the REI, like fairness analysis, and you just scroll down like fairness section, and like I just evaluate the module by using the art responsible AI principle, especially fairnesses. So I analyze the fairness across like two potential sensitive attribute, which about a gender, age group, and like for age, I divide applicant into the three groups under 30, 30 to 50, and over 50. Using the fair learn library, I compute fairness metrics such as selection rate, demographic parity difference, and equalize the odd differences. And the selection rate measure how frequently like applicant in each group are predicted as high risk. And the second is just measure whether different group are flagged as the high risk at a significantly different rate. And the last one is it evaluates whether prediction error differ across the group. So from the result, I observed the module behave somewhat like differently across the demographic group. For example, the selection rate differed between male and female applicants. So the age analysis show even stronger differences. So where applicant over 50 like are almost never predicted as a default. So now let's like about like module interpredict. So okay, so right here like I just focus on like module interpredictive. Like I import like very important for the sharp plot, SHAP plot. So next, first like for logistic regression, I examine the module coefficients to understand which variable increase or decrease predict default risk. A second, for random forest, I just examine feature importance to identify the most influential variable. So to provide a more detailed explanation, I also use the SHAP value. So the summary plot just show how each feature influence prediction across the dataset. So I also generate like local explanation using the SHAP force plot and a waterfall plot for individual like applicant. Also, so now let's think about like ethical consideration. So uh, I just think like I discussed like several risks associated with machine learning in the lending decision, and I discussed like several like rate first like historical leading like data sets maybe like contain institutional or societal bias which module may unintentionally learn. Second, if you like protect attribute are not explicitly used, some variable may act to the variable for a sensitive characteristic. So the human oversight can review are important for the responsible design. So now, like finally, I just discussed like consideration for the deploying like the module in the real production environment. So these just include like validation, import data schema, and next is monitor feature drifting over time, and now it's conditionally evaluating fairness metric. So this is all include metric in my project. As you can see, I showed all like the random forest the graph, and here's my wordy for the talk about like the final conclusion. So to conclude that, this project just demonstrated that machine learning module for the credit risk should not only just focus on the predict accuracy, they should also be fair, interpretable, and responsible deployed. Deployed. Okay, thank you so much.